So our challenging problem of today's session is this. If alpha is a real root of a cubic equation, ax cube plus bx square plus bx plus a is equals to 0, then we need to calculate limit x tending to 1 by alpha tan of ax cube plus bx square plus bx plus a by alpha x minus 1. This is a multi-conceptual problem, and to solve this problem we need knowledge of polynomials or theory of equations along with the concept of limits. Okay. First of all, initially I am just trying to analyze this particular cubic equation. See, if you look this particular cubic equation, ax cube plus bx square plus bx plus a is equals to 0, we learnt at polynomials from theory of equations. See, this is a reciprocal equation. If you look here, a and a as well b and b, coefficients of the terms from either sides are equal, and so we call it as a cubic reciprocal equation. Since the degree is 3, as mentioned cubic, since the degree is 3, it's a cubic reciprocal equations and it has 3 roots. Okay, right. And again, if you observe clearly, minus 1 is a root of this equation. When you replace x with minus 1, just check it. Okay, minus a plus a gets cancelled. When you replace x with minus 1, these two also gets cancelled. So clearly minus 1 is the root of this equation. And as they mentioned, alpha is a root, so alpha is another root. Since it is cubic as well reciprocal, for sure 1 by alpha is another root of this cubic equation. So finally this cubic equation has 3 roots, and they are minus 1 alpha and 1 by alpha. Okay, right. Since a cubic equation has 2 roots, we have this way of expression. Okay, ax cube plus bx square plus bx plus a is equals to, since these 3 are roots, okay, and leading coefficient is a is equals to, since minus 1 is a root, we will write it like x minus of minus 1, and alpha is a root, just write it like x minus alpha. Since 1 by alpha is a root, take it as x minus 1 by alpha. So if a cubic equation has 3 roots, minus 1 alpha and 1 by alpha, see, we know this way of representation, and now I will use it, okay, to find the limit. Now our task is to find limit extending to 1 by alpha tan of ax cube plus bx square plus bx plus a by alpha x minus a. We know that 1 by alpha is a root of this equation. So when you replace x with 1 by alpha, since it is a root, it satisfies, so it becomes 0. Denominator also becomes 0, and it is generating 0 by 0 format. So I am going to rearrange, manipulate this to find a finite limit value. So limit x is tending to 1 by alpha tan of this particular cubic equation. See, just for my convenience, if I represent this cubic equation polynomial as p of x, this is what tan of polynomial p of x divided by, I will divide with p of x as well, I will multiply with p of x divided by alpha x minus 1. Just have a look. I am just dividing and multiplying with the polynomial. See, as x is tending to 1 by alpha, okay, just look here, I am mentioning here, as x is tending to 1 by alpha, p of x is clearly tending to 0, okay, because 1 by alpha is a root of p of x. And as x is tending to 1 by alpha, since p of x is tending to 0, this tan of p of x is just looking like tan theta by theta, so its value is 1. So in the immediate next step, since its value is 1, we will write it like this: limit x tending to 1 by alpha p of x divided by alpha x minus 1. Is it clear? Okay, since this particular value is 1, this value is 1, and so we have a chance to write it like p of x by alpha x minus 1. Now what is the p of x? P of x is the polynomial. This is the polynomial. This polynomial is this a into x plus 1 into x minus alpha into x minus 1 by alpha. Now just replace, for space concern, I am just erasing this. I am just replacing this p of x with this particular product. What it is? A into x plus 1 into x minus alpha into, and this is x minus 1 by alpha. I am just rewriting it like this: alpha x minus 1 by alpha. Here the denominator is alpha x minus 1 clearly. Now it is very comfortable and easy for us to cancel out this alpha x minus 1. Then we have a along with alpha in the denominator, together two terms in the product x plus 1 and x minus alpha. So now replace x with 1 by alpha. This is equals to a by alpha into x is 1 by alpha plus 1. Again here x is 1 by alpha minus 1. So you just try to simplify this to reach the given options, and that's your answer at the end. This is the way of solving this type of problems where polynomial concepts along with limits are required. Okay, have a look.